Today's class is about unit testing. Okay? So unit testing is a practice that we in the industry follow to be able to determine if the code that we are the code that we're writing is correct or not, right? And sadly for that, we need to do something like this, and that's why you saw the meme in Slack. It's like we need to write more code to check that the code that we just wrote is correct, right? And then it's like, how? Like, why? Right? The problem with coding is that if you don't have, not testing, there is no guarantee for code that you write that is correct, right? You can write something like this. You can write sum of a and b, right? This is just a function that is adding two numbers, correct? But you can say, okay, a and b is this, right? Just because I like to put that -2 there. And then someone else, remember, that you're putting a coin and then you're expecting something out, but that something out is not coming in the right way. So someone come and say, okay, I want to sum 10 and 10. And you know that, looking at it, you know it's 20, but when this function is called in the middle of a program with variables that you don't know the value, etc., you assume that this function will add 10 and 10 or whatever and whatever correctly. But it's actually not, right? Because it's subtracting 2 here.
But that will be an error, right?
No, it's not an error.
Oh, it's not an error.
Because you're calling a function.
It's not in your parameters. It's not. It shouldn't be. You can do that on the return.
Yeah, exactly.
Parameters plus whatever.
Yeah. You can do whatever you want with your function. Your function can return anything, right? So how do you know that the function is actually doing? So we're going from the syntax, right? Syntactically, this is correct. There's no errors in this code. A plus b minus 2 is a valid expression. This is a valid function, except that the semantic of the function is incorrect. It's not adding a and b, right? So when you try to use it, like this person comes and say, okay, I will add 10 and 10, but it's not actually 10 and 10, it's a and b, and a is probably, the amount that you owe, and then b are the taxes. And then you're subtracting 2. That would be nice, right? But again, this is incorrect. The function is incorrect. So, but then how do you prove, and this is the point of unit testing, proving that your function is correct, right? So when you write the code, and this is basically a practice that we follow in the industry, it's like when you add code to a code base, you need to add also tests for that code, right? Especially if you are adding new code. Now, what is the purpose of this? Is that if you intentionally or unintentionally change something in the code base, right? You have a big function and you change something that functions are usually more complex than just adding two numbers, right? Functions sometimes have very long bifurcations or edge cases that work in a certain way, right? So if you have a function and you go to inside that function and you modify something in the function, so a certain edge case no longer works the same way, for that edge case, the person that wrote the original function will have a test that will say, run the functions, and if that test fails, that means that you changed something that's making that test fail, right? So we can guarantee that nobody makes a change that breaks the existing functionality. So that's the purpose of unit testing. It's basically guarantee that everything that is in production, the code is in production, works under certain parameters, right? And if code is added, then that code has to be tested. All the changes have to be tested, so nothing is broken, right? And actually, the way it works is that when you try to contribute to a code base, you actually need to get all the tests green to be able to put that change that you made in production. If not green, it doesn't go to production, right? If you don't add tests for it, usually your team, your peers will tell you, you need to add tests for this. This is something that is very like simple or not necessary, probably you get a pass and you just merge it and everything is fine. But usually, if you add new functionality, especially critical functionality, then you need to add tests for that, right? Not for a function that adds two numbers, of course, that would be silly, but usually functions that do very long transformations or have very weird edge cases, you need to add tests for those functions, right? And how do we do that, right? So it's basically writing functions. So you have a function that takes another function, but the way it works is interesting because it basically, the output, right? So you take a function, like I know that sum should like if I add in 10 and 10, that should be 20, right? So what I do is I say, okay, the parameters are 10 and 10, and the output should be 20. I mean, expressed as a function, right? So, and then I will say, well, -1 and 9 should be 8. And then I have certain cases like 0 and 0 will be 0. So I have a bunch of cases, different cases, where I try to give data where I know the solution, the output, right? If the function that I'm running, so this essentially will run sum of 10 by 10, and it will try to compare it to 20. If that's not equal, it will fail the test. But again, the beauty is that you need to add as many cases as you think are necessary. Let me explain. Let's say you have a function. You have a function where you only have, like, let's say we have the add function, right? The same add function, but we do this. And that's the only case that we have. Let's say we don't have any other case. So sum of 2 and 2 should be 4, right? Now let me go and fix my function because of course my function is broken right now. So if I have this function, I will copy here. So if I have this function, and this is the only test that I have for my function, right? 2 and 2 is 4. I would say, okay, I'm happy with that. Not good, right? Because I can come here and say, okay, you know what? Times, I modify the function, right? Super dangerous because it's like very different operation. And the test still valid because 2 times 2 is still 4. Right? That's why you need more cases. You need, like, for example, what happens when you do 1 and 0? This should be 1 because I'm adding and not multiplying. And then I will no, because the semantic of a sum is to add 1 and 0, so that should be 1. That's what I'm saying, is that the semantic of 1 times 1 plus 0 should be 1, right?
Okay.
So when the person came and changed that if this is the case, the test cases, and this person changes this function for times instead of plus, then this test the first test will just still pass, but the second one will fail, right? And then I know that that you made a mistake somewhere.
And how many test cases are?
That depends on the function. That depends because the function might have different scenarios, conditions, right? So you need to give them several inputs so you can check the output.
Like you have to think of all the possible outputs.
Yeah. And there is actually tools that allow you to check the cases that you didn't check.
Okay.
So there are ways to do that. Yeah, there is we will talk about that. So in this case, for example, this is a very simple function. Let's say you have the function. Let's say we have the function from earlier, the consonant function, right? This function. What would be a test for this function? So when I write extract consonant of hello, this should be equal to HLL,
Oh, yeah.
right? So this is one of the cases that I will add, right? When I run this function with this parameter, hello, it should return HLL. If it doesn't return HLL, that means that the function is broken. And that's how you try to approximate the semantic, the meaning of this function, right? Now, this is what we call an assertion. Let me see if I can move my cursor over here. Assertion. So these things here, this is what we call assertions, right? There are certain ways that we can express them. We will use a framework called Jest. So Jest is a framework. It's basically JavaScript that allows you to write assertions in JavaScript. So those assertions become your test, right? And are very simple. They're basically a function, test. You put the first parameter is like a human label, right? Let's say I'm testing 2 plus 2 should be 4. And the second parameter is the function that will do the actual test, right? So usually an arrow function. And then inside, you will say, well, you calculate the sum. Let's say the result. And you say sum of 2 and 2. Right? So you call the function with certain parameters. You have a result. And then the assertion is expect result. And I think it's to be, maybe it has a different signature, but something like this. To be 4. Right? So this is this is an example of how you write a test. So this function, notice that the test is a function. It has a parameter. It's basically a label, and an arrow function that will be executed. That arrow function that gets executed essentially runs the function that you want to test. I'm trying to test the sum function. That's the one that I want to test. And I call the function with certain parameters. When I know this result, I know the 2 times and 2 will be 4. And then I write the expression. This is part of the framework as well. Expect. And there is certain assertions that you can execute here. It could be to be, not to be. It could be bigger than, lower than, contains. There's a bunch of other things that you can do there, right? To express some shape of this result, right? In this case, it's equal, right? To be, actually, some frameworks that has to equal or something like that, maybe, or equals. Not sure. I mean, we will have to check the documentation, but yeah. Okay. So that's the way you write a test. Now, Jest is a library. It's actually from Facebook. So they wrote Jest. It's not the only one that exists in JavaScript. I think it's the most popular, I would say. And it's very good because you can write this type of test. You can write automated tests, and we will learn about those later, not now, because those are kind of harder to come by. But you can also write tests that run in parallel. Actually, tests, that's a pre-requirement, should not depend from one to the other. Like all tests should be able to run. Like you cannot take data from one test and use it in another test. All tests should run in isolation. So all the data is self-contained in the test, meaning self-contained in this function here. You should not use anything except for the function that you want to test outside of this test. It said that, some functions to help you craft the test, but other than that, you should not include something from another test. And the other important characteristic is that tests should run fast. Super fast, millisecond fast. The reason behind this is that as soon as your starts getting big, your application start getting big, right? You start adding tests. Like your code grows to at a certain rate, but again, every time you add code, you have to add tests. So this actually, the tests are growing even faster, right? And then you end up with 2,000, 3,000 tests, 4,000 tests. Imagine running 2,000. I mean, I've seen code bases that have 3,000 tests. Imagine if 3,000 tests and every test runs at, let's say, 100 milliseconds, 300 milliseconds. And 300 milliseconds is actually 3 seconds, right? Let's say that every test runs in 1 second. 3,000 times 1 is 3,000, so 3,000 seconds divided by 60. That's 50 minutes. So you're spending 50 minutes of your time in the day just waiting for your computer to start running the test, right? Not good. So that's why tests should run fast. On the millisecond, 2, 3 milliseconds, 10 milliseconds, as soon as the test start wasting time, like over 1 second, 3 seconds, even the JS will tell you this test is slow, like it's running too slow, right? Because it should be faster, because you want to run a lot of them. I mean, you have computers and they probably run in parallel, so it's faster, but still it's very. Questions?
I have a question. I think I know the answer, but are we supposed to write a function for each test case?
Like this? You mean like this?
Like a different function for each test case.
Not sure if I follow.
Let's say that function sum, and I need to do like 5 tests. Do I have to write 5 different functions for that?
Okay, so if I need to write another function here, I should do this. Test 0 plus 1 should be 1. So sum 0 and 1. And I would say expect result to be 1. That's my second test. So for every case, you need to write the whole thing, and you need to give it like a label. The label will help you understand what are you testing, right? And it's actually human. When I say human, it's like it's created for you to read, because the output of Jest. So when you run the Jest the Jest tool, Jest will take all these tests and it will run them, however they want to run them. But then you will only see that label with a check mark on the right? If it's green, it will be a check mark. If it's not passing the test, then it will be a red cross, right? So you will know what test actually failed. Oh, so if my function was not correct and I change it to be a multiplication, then it will say 0 plus 1 should be 1, failed, right? And then I can go to that test and see what's going on. Make sense? So that's what testing is, and I would say big percentage of the industry does it, right? Like it's really important. It's really important because what is the main reason we do this in the industry? It's because we want to ship code faster. When you go to a company and they don't have tests, what's the guarantee that whatever you're making is not breaking the whole thing, right? Because you can make a change and then you change something in some place, assuming that you know that part of the code base, and then that thing, when you put it into production, just fails, and then nobody can use the application crashes or whatever. It's because you didn't test the application first, right? So that's the point of that. So you can ship with confidence. Nothing gets cheap. When I say cheap, it's put into production without getting tested first. And if it's broken, it doesn't go. Your change doesn't go to production. It should be passing first. So when you go to a company that doesn't have tests, I would recommend that if you are getting your first job in the industry and the company you're working in doesn't have tests, consider another option. Because the thing is that you will break it, right? That's for sure. Everybody does it. I did it. Everybody that I know did it. But if you had tests, it's less possible to break it, right? Because if you broke it, it's because there was not a test for that. So you go to a company that doesn't have tests, you will break it for sure, and it depends on how bad it is, you'll probably get fired. and that's not a good
But
thing, right?
But breaking a function,
They
you're
usually
breaking
have
an
to.
app.
Yeah, you can bring an app or bring a function. That's for sure. I mean,
If you break a-
it could be something super simple, super simple, but that look, especially in the web, in React, there is a function that we use. It's like an effect function. If you're not sure how to use that function and you use it, that function can trigger like an infinite loop. What happens with an infinite loop? You already know, right? Crash. But if you have tests that checks your code, then you have a better guarantee that your code didn't break it, right? Now, that's the other thing. How do you know what parts to test, right? Because in a function that you write can be long. So most of these tools have something called coverage. So coverage is a number. It's actually a percentage. And coverage will give you what percentage of your code base is actually tested. I would say in the last years, there's some debates about how good is this number to assess that the code base is correct or not. Like some people say 100%, like when you have 100% coverage, that means that your app is tested in every possible aspect, right? That means that everything is tested. But some people say that not even having 100% coverage means that you have a correct code base. Because again, you're probably testing from the wrong things and you still have 100% coverage. Maybe your code is wrong and then your tests are wrong semantically. So your application is wrong. So 100% coverage doesn't make much sense there. But it's a good approximation of that, right? And most of these tools will give you they have like a coverage map, and they will basically take your code, they will put it in a web page, like very pretty web page, and they will tell you these areas are not covered, right? These areas are covered 100%, and this code is not covered, right? They will give you a coverage map of everything that needs to be tested. And to be honest, in most companies, having 50% coverage is good enough, right? 40% good enough. Some people say, okay, if you are really bad, like 10%, 20%, you probably want to bump it up a little bit. But getting 100% coverage is not, the cost is too much, and probably there is no benefit there. So once you get to a certain point, and you maintain that level, that's good. If you try to go above that, then it becomes harder because, again, every code that you write, you need to write more code to be able to test that code. So it becomes too costly. So again, remember, there is a cost benefit. So you want to keep it at a level, but not beyond that. Now, the last thing I will do before moving on to today's practice, and in today's practice, we will basically install Jest, write tests, and then create functions. Like the exercise is basically, okay, now you create a couple functions and write the test for those, right? And that's a LearnPack guided exercise, so it's really cool. But the last thing I would like to introduce before we move on to the practice is this. Some people call it the testing pyramid. I don't know. It's a pyramid, essentially, but it looks like this, and you can probably find it. I don't know why I'm drawing it, because I can probably Google it and find it faster. Actually, that's what I'm going to do. Testing pyramid. That's a good one. Now, the type of test that we are discussing today is that base of the pyramid, the unit test. And let me explain why this is the one we're focusing right now. It's because it's the one that is simple. It's the one that you have to write more, and it's the one that has more cost effectiveness, right? The thing is that unit tests you have a lot of unit tests. So the why is a pyramid is because they will tell you have to create a lot of unit tests, and then less integration tests. Integration are basically tests when you are testing functions that connect to other systems, right? So you have a function that connects to an API or something, that's an integration test. So you are testing systems that are not together, that they're not created in the same code base, but they work together, right? Those are integration tests. And then you have end-to-end tests, that's the top of the pyramid. But again, end-to-end tests are the ones that have the most value, because those are the most, let's say, the one that tests everything, unit tests, integration, but the thing is that they are the most costly ones. They are slow to run, and they take time to write. But again, the ones that, let me put an example of an end-to-end test. When you have an app, let's say you have an app that allows you to sell, let's say you're selling, I don't know, what do you call it, tripods, right, online. And you can configure if you want a remote, and if you want this, and you want it like that. So there is a certain interface in that app, right, for the user to select what type of configuration he wants. And then at the end, he can say, okay, I want this amount of orders, and I want to pay for it, right? You want to write a test that basically mimics the user doing the whole thing. Because as long as you have that test, and that test doesn't fail, you know that your app in production, people can use it, right? Because it's like a bot doing the whole thing, right? It's clicking this, clicking that, clicking there, here, and then pay with a fake card. It's not creating any orders in anything. It's just using the whole interface in a way where you know that everything will show up in the screen, everything will give you the right information, because you can test, oh, is it showing the tax implication? Is it showing the address, the delivery address? Is it showing how many orders did he want? Can he pay online or not, right? So you can check that if your application is running correctly on production or not. Now, writing that type of test is super costly. It probably takes a team of people some weeks to do something like that, right? So it's costly to build. It's also costly to run, because every time you run it, it's a bot just clicking. So if you're waiting for that test to run, that's a lot of time. So that's the cost, but the benefit is the highest, right? Because if you know that test runs, you can probably don't need unit tests or integration, because you know that everything runs from that point below, right? Now, because the cost, then you do unit tests. It's like an approximation. So you can move on, like most companies do a combination of unit tests. Like for example, my company does a combination of unit tests and end-to-end only in we call it the happy paths. Happy paths is where users interact, and they basically when the users pay. That's the happy path, right? If the user is not paying, if something fails, they will tell us and we will fix it eventually for them. But if it's like business, like dead or alive for the business, then we make an end-to-end test for that. Okay, make sense? So that's what the end-to-end test pyramid is essentially. It's like unit test, integration, end-to-end. Actually, my company doesn't do integration because we don't need it. But again, today we're going to build unit tests. Questions?
Where does it print out to? Because I don't see no count or log on any of the examples on the 4 geeks on the page. Like how do you know that it passed or it didn't pass, or there's no?
Well, the project, and let's go to the project, is this one. Wait, what is the project URL? Oh, this one. So go to the URL, and you need to